Hey YouTube, welcome back for another video. Today we're going to do something a little bit different. I know for a while now I've been saying that we'll do a coding example together, and today I thought I'd finally deliver. I think I have a good item picked out for us to work on that I think will be interesting and fun, and it comes right from my game, and it's also super applicable and helpful for anyone who's interested in OpenGL. So let's get into it. So for anyone who's ever done OpenGL development or learned about it, the website Learn OpenGL is pretty well a staple. It's one of the best resources there is. I know Joey, the guy who makes it, he has it in textbook form. But if you're really getting started, it's just a terrific resource. I used it throughout heavily while I was making my game engine, and I really would be lost without it. It helped me so much. And for the most part, all the examples in it are super, super helpful and pretty close to production ready, with one exception that I've encountered. For me, with my engine, I actually started out using DirectX, and then I switched over to OpenGL. I wanted to be able to run my engine on any platform, so I switched to OpenGL. And so one of the first things I did was I went to this resource, and I followed along in Learn OpenGL's guide for text rendering. And so it was one of the first things I did in my engine and brought into my game. And just before I shipped my game, it was actually one of the last things I had to update. Switching graphics cards, I found that this code was, I don't want to say really inefficient, but could really use some improving. There's a lot of spaces that could be improved in here. So I thought today we would go through and see what we could do to improve this and see what kind of performance benefits we could get. So I'm not going to spend too much time reviewing what's actually in the guide here or the tutorial. You're welcome to go through and follow along yourself. I went to the code repo, the GitHub, and I just downloaded a copy of it, and I've pulled it up on my side here. So this is, for the most part, exactly the way it was when it was published. The only things I've really changed in here already are the render text lines. I just generated some lorem ipsum, just some text to be able to use to draw on screen. We need to have something to draw. And I've gone through and I've added in these new lines. So \n, which is typically a new line. And then in the render text code here, I've made one change already, and that was I just checked to see if there is a new line, we're going to go down another line and have that vertical line break. So I made a new float here, which just copies the starting X position, and I just say if we encounter a new line character, we are going to move our Y position down a bit, and we're going to default, so just like a typewriter, we bounce back to where we were. This wasn't in this at the beginning, when you first get this text rendering tutorial, which I think is it's to me quite necessary, because it is very common to want to have new lines. So with that in place, you can see when we hit play, we get this lorem ipsum on the screen. The first thing I'm going to change right away with this is I'm just going to boost the resolution here. So we have these consts defined. So I'm just going to do 1920 by 1080. The reason why I'm doing this is it's just a more reasonable resolution. More often you're going to encounter this. We're going to start looking at performance. So I'm going to look at the frame rate a little bit. This isn't really, you shouldn't put too much emphasis or focus on the numbers we're going to get, but by doing a HD screen, I'm hoping it's a little more closer to reality, what you might encounter. I'm also going to adjust the Y here. So this is just 40 from the top. So when we run this now, now it covers my full screen. Okay. So this is a good starting point. This is pretty well unmodified with Joey's code, with the tutorial. The one thing I'm going to do before we start changing things is I'm going to bring up RenderDoc here. RenderDoc's a program that you can use to do shader debugging, or, well, really a whole lot of things with shaders. So I've got this all set up with my executable here. And we're going to give this a run. Actually, the one thing I need to do, I should mention, I'm doing this in release mode rather than debug. For code this simple, you might not see a huge difference. Just release is typically how you would release production software. It typically will be a little bit faster than debug. And in some cases, like with my engine, it's massively faster. So if I hit launch here, this just launches that same executable. And you can see up at the top, we get an estimate of the FPS happening here. Like I said earlier, these are not really numbers that you really want to etch in stone. It's really, I want to make note of these relative to the improvements we're making. Obviously, getting almost 400 FPS is very, very good. And really, we don't know how much this is going to impact the other rendering. Like I said, in my game, I had to update this because I found that my frame rate was actually being lowered by the text rendering. But for all you know, this isn't the worst offender in your game. Maybe in your engine you have worse offenders that are slowing down the frame rate. So with this right now, it looks like we're getting about 375, as well as not really caring too much about these numbers. I'm also going to say the way we're measuring this with RenderDoc, I know that there is more efficient ways to do that. This is not maybe the most efficient. So I'm just going to put in my spreadsheet here. Original, I'll say 375. Okay. And the other thing I'm going to do is if I hit F12 with RenderDoc, I can get a capture. So you can see what our output is here, and you can see all of the draw calls that are being made here. And maybe if you're following along like me, when you see this, your programming spidey senses start to tingle. So as you can see, there are hundreds and hundreds and hundreds of draw calls happening here. So when I came close to releasing my game, I talked about it in the last video, I bought an AMD graphics card. And I found when I switched from my NVIDIA graphics card to the AMD graphics card, there was a big performance hit in doing all of these draw calls with the text. So to really call it out here, what's happening is every single character is requiring a draw call to render on the screen. And obviously this is something that we can improve. We could render all of the text with one draw call if we start using arrays. The one other thing that maybe isn't quite as noticeable here is as we go through this call here, this is rendering space. You can see over here with the image that's being used, that's being sampled, it's rendering a space, which is nothing. So we can also improve things by skipping over spaces. There's no need to do a render call if it's not actually going to draw anything on screen. Okay, and I'm getting a little ahead of myself. We're going to start making use of these improvements right away. But the one other thing I wanted to show, if I could find it in here, the mesh viewer. So the one other opportunity for improvement that I noticed that I took advantage of is with this current rendering pipeline, with the way we're drawing text, we actually send the vertices in their correct positions on screen right away. And so over and over again, we're editing the buffer, the vertex buffer that we send to our shaders with the locations we'd like. We're going to go through and we're going to change this. So instead of sending those specific positions into our shaders, we're going to have the vertices just be a set box, and we'll use a matrix to then transform them. And we'll see, I think that we'll get some performance improvements by doing that. Okay, so with all that being said, let's start with that space improvement, because that's actually a pretty easy one. Okay. So to do that improvement, all we're going to do here is we're just going to say else if. So right now we check to see if that character is a new line, then we're going to move down. You'll notice we also don't do a draw call if it's a new line, because if we have a line break, we don't need to do any drawing. We're going to say else if c is equal to space. then all we're going to do is advance our X position, our horizontal position a little bit. While we're at it, if we wanted to, we could also handle \T for a tab or some different items. As it is, though, this is what I've gone with in my engine. And so if we try this now, we're still drawing, that's good. I'm going to now try this with RenderDoc. Okay, so already by skipping over those spaces, you can see we've gone from about 375 to, I don't know, 440. And it's, once again, I know I'm going to keep saying this, super important to note that improvement is completely dependent on the text, right? The more spaces you have in your text, the more this improvement is going to change performance. So this improvement is obviously, no matter what, it's a positive. It's going to improve things, but it's going to vary a lot how much it improves things. So I wouldn't really put too much in how much things have changed here. So I'm going to say 440. Okay, so we've already improved a little bit here. So with that change done, the next thing we're going to do is we're going to try changing our vertex buffer like I was mentioning. So in our render here, you can see we have our vertices that we set up with every single draw call, and we update our buffer, and then we draw with them. So every single time we're changing the vertex data we're sending to the shaders with these correct positions, and then we're using our projection matrix and drawing it on screen. Sorry, I should have showed this earlier. So in our vertex shader, we're assuming our vertex that comes in already has the correct X and Y positions, and we're multiplying it by a projection matrix, which if I scroll up here, is just a screen ortho projection matrix. Okay, and then in our fragment shader, we sample our texture, I guess, and we have the ability to change the color. So what I'm going to do now is I'm going to add in another matrix, which is going to be responsible for transforming that incoming position. And I'm going to set our incoming position once to a kind of generic rectangle that we'll be able to reuse over and over again. Okay, so to do that, we need to set up this buffer. Sorry. So right now, we create our vertex buffer object right here. And you can see we size it and we set it to dynamic draw. Okay, trying to keep up with my example. All right, so we're going to change some things in here. So first off, you can see this is drawing 6 vertices that each have 4 floats. So it's 6 vector 4s. This is really not necessary for 2 reasons. First off, I'm only concerned with the X and the Y position, and we can do a little trick to get the UV coordinates from that. So that'll take this down from a vector 4 to a vector 2, because we just need the 2D position on screen. And then the 6 items here, that's doing 2 triangles to make our quad. I'm going to switch that to 4, and we're going to do a triangle strip instead. So it'll be a little bit more efficient that way as well. So I'm going to make an array here. We can call this whatever we want. I don't know, let's call it like vertex. Oops, vertex data. And this is just going to be super easy. Okay, 2, 3, 4. All right, so there's 4 vertices, each one being a vector 2 with an x and a y coordinate. And we've just left them sized with 0 and 1, which we can multiply with our matrix to transform to the right size and the right location. And so we can now change our setup here. I'm now going to update this to just say size of vertex data. And then instead of providing null data here, I'm going to provide that vertex data. And now something else that's quite important is instead of being dynamic draw, we're now going to switch to static because I am not going to change this anymore. That can be a bit of an expensive operation. I wouldn't say that I knew immediately that this would speed things up quite a bit, but there was a pretty good chance just because we were changing that buffer over and over again before we render every time. Now with the vertex attribute pointer, we now have 2 items instead of 4. Still floats. False is good. I'm going to just default this. This is our stride. If we set this to 0, it's just going to assume our stride fills our whole length, and that is good. So now our vertex data is good, which means we are no longer going to be creating this array every time. This already is just kind of bad form that we keep creating this 24 float array over and over again. This could have been optimized by moving this up already, but we are going to comment that out for now because we're not going to use it anyway. All right. We also don't need to update our buffer anymore. So get rid of that. Okay. I'm also going to move this bind buffer down here. Okay, so what else do we need to change here? Well, first off, we can change our draw arrays here. So part of the reason why I want to change this to a generic rectangle is I want to be able to do an instanced call. So I want to be able to call our shader multiple times at once. I want to say draw this whole sentence, and I want it to be able to work on every single letter in that sentence. And so by having the vertex data all be the same, that's going to make things more efficient and make us able to do that. So I'm going to switch this over to draw arrays instanced. Now, right now, we aren't going to be using the instanced portion of this. We're just going to be doing single calls, but that's okay. So I've switched this to draw arrays instanced triangle strip. So we're no longer doing triangles. It's now a triangle strip, which is why we have 4 vertices instead of 6. We're saying our first one is at 0. We're doing 4 vertices, and we are drawing 1 instance of this. As we go on and we do multiple letters with one call, this number will change. Okay, so that's looking pretty good. The new thing we need to now add is we need to add that matrix, which is going to transform our generic rectangle into essentially what we have now or what we had before. Okay, so I'm going to update this a little bit. I'm going to change this matrix from projection to screen projection. Doesn't necessarily have to happen that way. Actually, you know what? Maybe I'll just leave it. And I'm going to add another uniform mat4. This time, I'll call this one transform. You could call it whatever you'd like. And we are going to multiply that. Now as well, we've gone from having a vector 4 coming in to now just being a vector 2. So we just have the position. Okay, so this matrix is going to take care of placing and sizing our generic rectangle now. So if we go back, we're going to need to set up that matrix, and similar to what we have, or was it with our projection call here, we're going to have to do the same every time we go to draw. Okay, so why don't we add a matrix? I think that pretty sure we're not using namespace. I'm going to add the GLM namespace just to make my life a little bit easier. And we'll add a mat4 transform. Okay. This is all just in this CPP. Obviously, if we had a header, I would make use of that as well. Okay. So now, down here, every single time we were changing our vertex buffer, instead, we're now going to be setting up our matrix. So I'm going to keep these X pose and Y pose. I'm going to have that transform. And I'm going to say it's equal to translate. The starting matrix is just going to be an identity. Then the position we are going to is going to be our X pose, Y pose, and 0. And then we're going to times that by our scale. The scale is an interesting one. So you can see here, we have our X and our Y here, or sorry, our width and our height here that we were using to figure this out. We're going to do this slightly different. So scale, use mat 4 again, and a vector 3. Okay, so we have our scale coming in. It doesn't like that we've named a variable scale as well as the function. So what we're going to have to do here is, you can see what we've done here is we're multiplying the scale by the size of each of our characters. So because our generic rectangle we've set up is size between 0 and 1, we need to once again do the same thing here of multiplying the scale by the actual character size. And as we keep going and we update things, you'll kind of see how that comes into play here. I could just reuse these and paste them up. I don't know why I didn't, but. Okay, so we set up our transform here, and then once our transform's set, I'm going to make use of this. Okay. So we are going to set that mat4 with that transform. Okay. I like to use Sublime Text. Also, I didn't call this out for shader code rather than visual. All right. The only other thing I'm going to change here, this is a personal thing. You don't have to do this at all, but I prefer, instead of using this value pointer, which I'm sure works just fine, I just like going one more. I have too many. There we go. All right, let's leave it as it was. Maybe we'll fix that later. Let's not make my life harder. Oh, it's because I had an extra. That's okay. Okay, so let's see how that works. Let's see if I've skipped anything. Clearly, something has gone wrong here. Okay, let's make sure. We have some issues. Right, I forgot to update the shader. Okay, so our transformation is working all right here, but I forgot to update the text coordinates. So in the past, we were sending the text coordinates as the third and fourth float in our vector 4. I'm not going to do that. I'm going to make use of the fact that we know what our vertices are going to be. So I can just make use of these with our UV coordinates. It's a little bit of a hack, but this is what I like to do in my code. Okay, so I'm going to say text coordinates is equal to vertex xy. And the other thing I need to do, unfortunately, it's a bit of a pain in the butt, but the y is actually inverted. So I'm just going to say y is equal to 1 minus y. Okay. Let's see if that gets this running again. Oh, still have an error. I wonder if that didn't pick up that change. Okay, sorry about that, but for some reason it didn't pick up the vertex shader change. Hopefully that doesn't happen again. But so we're up and running again now. Now that we have this change in place, let's take a look at it with RenderDoc. Okay. So first off, immediately we see a big performance improvement. So we're now up to, I don't know, like 710, 715. It's kind of all over the place. Let's maybe say 710 just to ballpark it. Sorry, I'm just changing my spreadsheet. Okay. And let's take a look. I saved a capture. So now, first off, you can see we're not rendering 6 vertices every time. We're doing 4. And if we look at our mesh viewer, you can see coming into all of these, we just have this generic square. And coming out of the vertex shader, it's placed on screen where we want it. Nice. So already we're doing pretty well here. I don't want to focus too much on these numbers. You've seen already it varies a lot, but we're looking at almost a twice as good improvement. But there's still a lot left on the table here. So our next change we're going to make is we are going to consolidate all of these draw calls into as few of them as we possibly can. So we're going to do this by using arrays and by using a sampler array. So when we look at our vertex shader here, we are going to update this so there's an array of transforms. So because we're going to do this call and we're going to render all of these letters on screen at once, we have to send all of the transforms we need. And we're also going to update this so there's an array of textures, because instead of just drawing one letter at a time and setting the letter we're going to be drawing, we're going to be sending all of the possible letters. We'll add in another array to index which letter we're going to be using when. Okay, so this is a bit of a big change. I always try and make manageable jumps in code to see what's broken. Unfortunately, this one is a bit of a sizable one. But the first thing we're going to do here is we are going to change the way we load each of the letters. So you can see prior to this, every single time we were generating a texture for an individual letter, we're going to update this so that we can use an array. Okay. The nice thing with this is still going to be OpenGL 3 compatible. So if you want to stay on legacy hardware, you're not going to have to update, which is quite nice. Okay, so maybe we'll start with our shaders actually. So we're going to need an array here. Now, the size of our array, this is kind of an interesting point. The larger this array is, the more letters we're going to be able to draw at once, but individual graphics cards are going to have specific limits for this array. So you could try and replace this with like a UBO or a SSBO. I'm not sure the performance implications of that, but they should be able to avoid having the problem of running out of array space. But because we're just using mat4s, this should be okay. This is what I have in my game right now. I'm using 400 at a time, but the more you can maximize that, the better the performance you're going to get. And we're going to kind of go through that. So as I change this to go alongside it, we are going to set up another const. I'm just going to call it array limit. And I'll set it to 400, just so we can keep that in line. And that way, if we want to change anything, we can after the fact adjust it. This is not necessarily always the case, but in games, when you go to start your game and it says compiling shaders, sometimes it's things like this where it'll look at your individual graphics card and try and maximize the size of arrays. And so it recompiles them and it rewrites them. Now, because our transform here is now an array, we need to access it at an index. And the index we're going to use here is GL instance ID. Oops, forgot the N here. Okay, so this means use the index in this array dependent on what instance ID we're using. So what instance call this is. So if we say draw 100 of these, if this is the third character we're drawing, we're going to use the third matrix, and we'll just make sure that those line up when we send them to our shader call. Okay, so this is good. The only other thing I'm going to update here is right now we're just passing along a vector2. I'm also going to pass along now an index. So this is just going to be that GL instance ID. We're going to need it in our fragment shader. So I could do this. Right. But at this point, we now have two items we're passing along. This is going to make a huge difference doing this, but it's good form to group them together. So I'm just going to say out, yes, out. Okay, and we'll name that yes, out. Okay, and then for all of these, we have to say all right. So that should do it with our vertex shader. So now we've updated this so we have an array of transforms. We've grouped what we pass along to our fragment shader, and we say we're going to have texture coordinates, and we're going to have our index for which specific character we're drawing. Now, over here, first thing we need to do is we need to copy this struct. And so instead of text coordinates as in, I'd like to put this below. We're going to say in is our VS out. Those guys are the same, and I'm just going to name this FS in. Okay, so right away we can switch that there. All right, so we have that coming in. The first change we're going to make here is instead of a sampler 2D, we are now making a sampler 2D array. So this is going to be an array of textures. Now, with this array of textures, you can see when we load all of the characters right now, we load the first 128 characters of the ASCII set with our code. I'm going to mimic that, and I'm going to make it so that sampler array has 28 textures for each of the individual characters. And so the reason for that is I don't want to have, what I could do is I could make this 400 long, and I could have it set up so you have to access the individual index for each individual character. What I'm going to do instead is have each index be the related character, and I'm going to use another array of ints to defer to what index we're at. So the reason for this is, let's say you have the word ABBA, right? So you have A, B, B, A. If I were to directly map these here, I would need to store the texture for A, the texture for B, the texture for B, the texture for A, right? Which would be inefficient. And I don't want to really touch this very much because dealing with textures can be inefficient. Instead, here, this is going to say access at index 0 for A. I don't know if it actually lines up with ASCII, but you know what I'm saying. Access index 1 for B, access index 1 again for B, access index 0 for B or for A. Okay, so this lets us indirectly access that. So that's all good. We're going to need to update our sampling code though. So we're still using that texture. However, We have to make this a vector 3. The coordinates are going to be the same, but the depth in our sampler array, or which texture we're going to be using, is going to be this Z value. So we're going to say letter map at index. Okay. So take that index coming in, saying this is the third character we are rendering, then use that index inside of our letter map, and that'll tell us which character we're trying to render and therefore which texture to use. All right, that looks good. I feel like there's probably still a decent chance I'm going to go to run this and get an error, but that's okay. So that's our shader side taken care of. Now we do have a decent amount of work here to update how we load our textures and how we send this along. Whoops, hitting all the buttons. Okay, so here is where we load our texture. And where do we initialize? We have our texture ID here. And so every single character we load, we generate a new texture, and then we generate our image. What we're going to do now is above our for loop, we are going to generate our 3D texture. Okay. First thing, you'll see our starting code here, set pixel sizes, is set to 0 for X and 48 for Y. So this means try and size it so it is 48 for Y, and whatever X size that is, that's okay. The change we're going to have to make is prior to what we're doing, you can see each character has a different size for X and for Y. And this makes sense. Like if you have like a letter like a lowercase l, it's quite thin, right? So its X, its horizontal size is going to be quite small, and its Y, its vertical size, will be quite tall. What we're going to do now is I'm going to say that every single texture is going to be 256 by 256. And you can load, you can be smaller, and L can be kind of wasted space in that 256, but we're going to standardize it because this 3D array is going to have 128 textures that are all the same size. So I'm going to say try to set the size to 256, 256, and we're going to make use of that as we go. Okay. So up top here, I'm going to add in a for our texture array. I think this needs to be capital. You'll see sometimes the Learn OpenGL likes to use unsigned ints. I always use GL unsigned ints. It's the exact same data, but okay. So with that variable declared, we are going to generate our texture. We're doing one of them. I really should be copying this, seeing as this is code that you don't really need to be calling off the top of your head. You can see it's the exact code we've used here. Okay, so I'm going to say GL active texture. Not even sure if we need this, but slot 0. GL bind texture. Now, one of the interesting things here that we have to make sure not to forget, and I feel like somewhere I will forget, is we are no longer doing a GL texture 2D. We are now doing a GL texture 2D array. Okay. So this is going to bind that texture. It's all set up. Next, we need to set it up as a 3D texture. This is a bit of code that can be a bit of a pain in the butt and can have some issues. I'm just going to copy this section. Okay. So the current level is 0. Our internal format is going to be GL R8. So we just have a single channel of color. These are like they're black and white are images. So we're saying 8 bits for red, and that's it. Okay, it's going to be 256 by 256. The depth is going to be the number of textures here, so that's going to be 128. Our border is 0. Our format, GL red. I always get these mixed up, but I'm pretty sure I'm good in this case. And then the type is going to be unsigned byte. And we're starting out with an empty row. Okay, so this is set up our 3D texture at the top here. And now as we go through and set up each individual character, we're going to load it into that texture. The first thing I'm going to do before I forget is right now, all of our texture options are set to texture 2Ds. I'm going to swap those over. All right. Okay, so in here, we no longer need to generate a texture every time. Instead, with each call, we are going to be doing GL text sub image 3D. All right. So it's going to be pretty similar, but a little different. So we have a texture 2D array. Now our level is 0. Our X offset, Y offset, 0. Now the Z offset is what index this texture is going to. And so I'm going to do int C, which is going to represent the characters in our ASCII set. So this means whatever is the first character in the ASCII set is going into the first index in our array. Now we're going to use the same face, glyph, bitmap, width, and row. Type it out. Face, glyph, bitmap, width. Okay, I might just copy and paste. I'm typing in between my microphone here, and so it's not the most ergonomic. It's going to be rows. Okay, next up is our depth. This is going to take up 1 space. Our format is going to be GL red. Next up is our type. Once again, it is unsigned byte. And now our raw pixels is going to be the buffer again. Okay. So we've now set it up so when we use our free type to load our characters, we then place it in our 3D array. The thing we need to change now is prior to this, we have this struct character that we've created. And before this, this texture ID was a handle to the actual image, was an unsigned int. What this is now going to be is it's going to be the letter in the index of our ASCII character. So if it's the first ASCII character, it'll be 0 and so on. So I'm just going to set this to an int. I should really change the name, but I'm going to leave it. Okay. And so instead of being texture here, this is going to be int C. And we're going to actually make use of that as we go. Okay, so that's looking good. We make sure we bind 0. That's done. Okay. I feel like there's still a decent chance I'm going to forget something as we go through here, but that's okay. Okay, so our sampler array is looking good. Now let's make sure that we set up an array or a vector I'm going to use of ints for our letter map and of mat4s for our transforms. Okay, so up at the top here, I'm going to add, I'm guessing this doesn't have vector in it already. No, it does not. So I'm going to use C++'s dynamic array vector. Just for simplicity, this could be an array. It's not even going to be resized, so, you know, probably a decent argument for just an array, but And of course, we don't have std, do we? Using namespace std. Vector map 4. So I had this mat4 transform. I'm going to replace that with a vector mat4 transforms. And I'm also going to have our int, which is our letter map. So let's just call that letter map. Okay, so that looks good. The only thing we need to do with these is before we go to use them, we should make sure that we've sized them properly. So maybe down somewhere in our initialize, before we set up our VBO, we can do this anywhere really, but I am just going to do a for loop, size equals 0, I less than, and I'm going to make use of that array limit. So if we change, this code will also change. And for our letter map, we're just pushing back 0. For our transforms, we're going to push back an identity matrix. Okay. And the reason why I'm doing this at the start is I want to be able to, when we go to render, just blindly access at individual indices. I don't want to have to push back. So this will just make sure at the start there are 400 indices set up. Okay, so that's all looking good. We're going to have to bind that when we go to use it, but we also in here are going to need to make some changes. So I think we're on to our render text here, which is good. Okay, so first off, prior to this, every time we went to render a character, we had to bind that texture, that individual texture that we were going to be using. Now, because we have this array that's going to be used, we're just going to bind it once. So I'm going to take this code, put it up here. It's now going to be our array. So because every single letter is going to be using the same texture array, our same, what do we call it, sampler 2D array, we just need to bind it once and everybody's going to make use of it. Okay, so that's good. The next thing we're going to need to do is I'm going to need to make a variable to keep track of what letter we're working with. And the reason for this is as we go through, we need to know I'm accessing transforms at 5 or 10, right, as we go through. So I'm going to make an int working index is equal to 0. Now, something that's really important with this working index is we want to make sure that we don't count the new lines and the spaces, right? Because if we did, we're going to be wasting space in our arrays again. So down at the bottom here in our else, if we know this is a good character, I'm going to say working index plus plus. Okay. That's good. Now, with our transforms, access this at working index. Okay. So this line is pretty good. Now, instead of just accessing one mat4, we're doing at our individual index. And the other thing we need to change here is we're no longer just using our size. We're going to use 256. Now, to go along with that, there's actually going to be another change. And this is something that if we had started this project from scratch, we wouldn't have to do this. But because I'm trying to get the exact same output on screen as what we had before, I'm going to have to do this. So I'm going to say our scale is equal to scale times 48 divided by 256. The reason for this was before we were scaling our letters to 48. Now I'm scaling them to 256. And so this is just adjusting that scale value to be in line with that. Okay, it's a bit of a pain in the butt. If we were to start this project from scratch, we just wouldn't have our scale set up to that, but it is what it is. Okay, So that looks good for that. The other thing we need to do here is we need to set up our letter maps. So we're going to say letter map at working index is equal to ch.texture ID. So if you remember, this is the character number for each individual letter. So if A is 0, this would be 0 when we go to draw an A. Okay. Now, I think we're doing well for setting up our data. I think the only other thing I want to do before I get into the actual draw call is this working index. I want to make sure that we don't ever pass 400. For the time being, I'm going to make this so we just do one draw call and we do 400. After we get that up and running, then we'll make it so if there's more than 400, we do multiple calls. So up at the top here, I'm just going to say if working index is equal to array limit -1, then we'll break. I think that should work. We'll see. I think we'll catch it if it doesn't. Okay. Now, a little bit of trickiness here. What we're going to do next is we need to move all of our draw call information out of this loop because we're not going to be doing it every single letter. Instead, we're going to be prepping all of our data, then doing it in one call. So outside of this for loop is where we're going to be doing it. So we're going to need that transforms. I think now I'm going to make use of my setup. I guess I probably could have used there still, but okay, because this is, I guess switch that to transforms, right? Nope, I left it as transform. Let's switch that. Okay, so because this is a vector of mat4s, I had to add in one more 0. Next up, we're going to do that letter map. So it is called letter map. Okay, now this isn't a matrix anymore, so we're going to do GL uniform 1 IV. Okay. Get rid of that, and this is going to be okay. Now before I was doing one item I was setting, now that's going to change. For the time being, we're going to do our working index. So we're going to update with working index number of items. Okay, that's looking good. We can move that to here. Actually, you know what? We can move that up here. Yep. Okay, and now we're also going to move our draw call down here. Now, instead of doing 1, we're going to do working index. Okay, this is looking good. I feel like there's probably a decent chance I have some issues, seeing as we've changed so much. And there's a decent chance that my shader changes don't get picked up again, but let's see what happens. Okay, it worked. So we have our first 40 characters. Obviously, this is not the full amount yet. And you'll notice we have some issues with our vertical. Now, this is kind of an interesting problem. The reason why we have these offset issues is with our text rendering, some time was spent with the fact that there is a Y offset in these characters. So G is a good example, right? Where G is, you kind of have the circle placed right on where you would have your line of where you write all of your characters. So G is offset a fair amount vertically. Right now, we're not taking that into account. So let's see if we can do that. Okay, so right now we're still using our size we had before. We're going to change that to 256. And if we run that, nice, looking a lot better. Okay, so this is not going to be a fair test to use RenderDoc on this. The reason being is obviously we're only rendering 400 characters, so clearly there's already we're improving our performance by eliminating characters. But let's just get a ballpark and see what's happening. So already you can see big improvement, right? We're around 6,000, it looks like, which is a whole different kind of stratosphere than what we were dealing with before. So that's great, but let's finish this up and see if we can set this up and really be able to see how much of an improvement we have here. All right, so what we need to do is we need to make this so if we go past our 400 limit, we do a render call of that 400 we've set up, and then we continue on with what we've got. So what I'm going to do is I'm going to add in another function, which is going to do the actual drawing. And then in here, we'll have an if check, and we'll say, if we've reached 400, initiate a call, and then just continue on. Okay, so up at the top here, I'm going to add in a function. I feel like it's hard to come up with a good name when render text is already there. So I'm going to say text render call, probably not a great name, but that's all right. So I'm going to give it an int for the length, the number of characters we're rendering. And I'm going to give it access to our shader because I don't think that that's made available in this. Okay. So we'll go down here and we'll add this in. Okay. So let's do a safety check and we'll say if length does not equal 0, we'll just make sure that it's good. This length is going to be that working index. And you might think, well, why don't we just default to 400? If you go to render, 100 characters, there's no point in doing 400 and having 300 be just blank. So we make sure that we have access to that working index as a result. Okay, so I'm going to copy this in. Okay, so here we'll swap these guys for just that shader. Do that. And instead of working index, we're going to use length. So that looks good. Now, what we need to do is, instead of doing our break here, we're going to initiate our call. So I'm going to put this at the bottom. So we add to our working index. We're going to say if our working index is equal to that, call text. Maybe I have a capital to match their style, render call. We're going to give it our working index. We'll give it that shader ID. And then I'm going to set working index equal to 0. Okay, so by setting it equal to 0, this is going to start again at the beginning of our array. But because we're still in this for loop, we're not going to miss off where we were. So we're still at character 41 or 401 here, but now we're at index 0 here. Okay, I think this is good. I have an itching suspicion I've forgotten something, but look at that. So we get everything on screen. And now the golden question is, how does this look with rendered? Look at that. So we're still at 5,000, even with all of those characters. So even if I'm a little bit conservative, just because it is oscillating so much, we've now gone from, once again, I don't want to really focus too much on these numbers, but I just want to focus on the percentage change. We've gone from 375 to 5,000. So we've almost 10 times our performance here. And this is really great. So with that, we've gotten massive improvements in our performance with the text rendering. I found in my game, like I said, when I switched to an AMD graphics card, I found that this was really a bottleneck for my game. I would drop a lot of frames, where making this change really improved things. I found that the NVIDIA card was mostly okay. Before, with the individual calls, it also benefits from this, but I found that this really made a big difference with AMD. I think that's because AMD prioritizes memory bandwidth over the speed of the individual card, but one slight addendum. I just found this as I was going through. I gotta move my head. You guys can't see it with how I had this before. So with the code we wrote, I noticed at the end here, it's always hard to tell using lorem ipsums because you can't really pay attention to individual words, but we get cut off at this AL, which when I go through and look here, is not the end of the text. The reason for that, or I think it's this guy actually. The reason for that, I just realized, is I'm only calling this, when we've exceeded our limit. We need to add in one more call here when we finish this loop. So let's, I could do a check here and say if working index is not equal to 0, do this call, but I actually already handle it here. So if I hit play now, now we have all of it. Okay, so now that we fixed that, that'll finally do it. So hopefully you guys enjoyed following along an actual code example with me. Like I said, Learn OpenGL has really been super useful for me and really just made a huge difference in my engine development. So when I saw this code had the opportunity for some improvement, I was excited to be able to do that and hopefully share this with people. Let me know what you guys think. Let me know if you want to see some more code guides, and have a great day.